Welcome to my channel Code Doctor. Today we are going to solve a problem called square root of x. So the main intention is to understand what is the intuition behind this problem. So when somebody asks you find the square root of x or find the cube root of x or find the power of x, there is a common algorithm, or you can say it's a common crux of the problem is same. So we need to implement a square root, and we have given input integer as x, and given output return type should also be integer. Okay, so what does that mean? If you have 8, the square root of 8 is 2.82, so we are only interested in integer part of it. Square root of 4 is 2, right? So yeah, that's the problem is. Now take an example as 16. So you need to find the square root of 16, which is actually 4. So let's say you have numbers like 1, 2, 3, then 8, 9, and then 16, right? So we can use something called binary search approach here. We look for the middle element. So when we see 8, now 8 is the middle element of a range of number from 16. So 8 square is actually greater than 16, right? That means we cannot find a square root of 16 on the right side of it. We can always find on the left side of it. So in that case, the next numbers we will look for this range. Now next we will look for mid, which is 4, and the 4 square is equals to 16, right? Here we can return 4, right? So that's the basically binary search approach. You look for the middle element and just square it and compare with the given input. If it is equals to the x, then you can return the value. Otherwise you check if it is greater than or if it is less than. If you say if it is less than, mid square value is less than value of x, then you look for the right side of it. And you need to store your output when you go for a right side. So let me just walk through it. So the base case will be if the x value is 0 or x value is 1, then we can just return x. Then we can start value, we can have end value. Now in binary search we do something like this. We have a start and end. Now we try to find the mid value, which is start plus end divided by 2. We can find the mid square, which is mid multiply mid. Then we check if the mid square is equals to given value, then we can just return mid. But if this mid square value is less than x, then our start will become mid plus 1, and we can store the answer value as mid. Else end should become mid minus 1. That's it. So you can see for the case of 8, if you have 8, then let's say you have 1, 2, you go up to 4, and then you go up to 8. So first you check for 4. Now 4 square is actually greater than 8, so you look for the left half. Then you have number this, right? So we can say 1, 2, 3, 4. Now the middle element is, let's say 2. Now 2 square is 2 square is 4, which is less, right? So you look for the right. So that is, you look for only 3 and 4. But you already store answer here. The answer value is 2. So now the mid square is 3 square, which is greater than that. So you just stop it there. The recursion will get stopped. So not the recursion, just the while loop will get stopped. So the time complexity will be log of n, because every time we uh, reduce our domain or the range of input by half, and the space complexity will be big of 1 because we are just storing in variables. Let's run and see. Perfect. Thanks for watching this video. Please subscribe to my channel for the upcoming videos. See you soon.